Hello, so today I'll be talking about linked lists and stacks, right? In the previous video, I told you about data structures and their types, whether they are simple or compound, which is later on divided into different other data structures, right? So today we'll be discussing two of them. First one is linked list. Now, linked lists are linear data structures and it is very common data structures, which it consists of groups of nodes in a sequence which is divided in two parts. Now, each node contains its own data and the address of the next node. Right? So, a linked list looks something like this. Has a rectangular box. Okay. This is a linked list. So now this will contain the data of its own and the address of the previous and the address that is of the next node that forms a chain. So this is the data, and this will be the address of this node, right? Okay. So now these are also linked lists can also be used to create trees and graphs, which is one of the uh, compound data structures that we had seen, right? Now, when it comes to advantages of linked lists and why we are using this, so when we use arrays, like if we declare an array, let's say we have an array int name 10, right? So here we have declared the memory that we need, that is 10. So now if we need to add more memory, let's say later on, we cannot do that, right? We cannot add. And we also, if let's say we have assigned 10 memory, but we end up using only 2 of them, the rest of the 8 memories will be wasted, right? So these are not very memory sufficient when it comes to arrays, but whereas in linked list their dynamic memory allocation is possible. So whenever we need more nodes, we just add them to the list. Like we need one more node here, we just add one here, we add the address over here, and then we keep adding. If we want to, if we don't want it, we won't add it, right? Now operations like insertion, deletion, etc can be very easily implemented. So insertion, like I told in the previous video, is when you want to add some element, and deletion, of course, as the name suggests, is when you want to remove or delete an element. Now linked lists can also be used to execute stacks and queues. We'll be seeing what stacks and queues are later on. And because of these dynamic memory allocation, linked lists are very easy to accessible, and it also reduces the time that we need, because the memory can keep adding on when you need it, and there's no wastage of memory or extra memory that is kept, right? Now when it comes to disadvantages, right, the disadvantages is that the memory is wasted as the pointer require extra memory for storage. So whenever this does have dynamic memory, so it is better than the array part, but still whenever we have a pointer, because we have an address over here, right? So the address is the ampersand, so this is a pointer, right? The ampersand or the pointer symbol here, this takes a lot of memory to be stored, hence there's a lot of memory that can be wasted also. And also no element can be accessed randomly, right? So all these nodes are in a sequence. We have this node, and then we have this node, and then we have this node, so you can't randomly pick up this memory out of here, you have to go in a sequence. Now if we come up to the applications of linked lists, then linked lists are used in implementing stacks and queues, graphs, trees, etc, like I've told. And they also let you insert elements at the beginning and the end of the list. You can't randomly access memory in the middle and add stuff, but you can access them in the end or the beginning and then add elements or delete them. And we also don't need to know the size in advance, like I told over here. In arrays we needed to know the size before we created an array, whereas in linked lists you can just keep adding them. Now linked lists are of three types, that is singly linked list. Now singly linked list contains nodes which have data part as well as an address part, that is the normal linked list, and in the next, which points to the next node in sequence of the node, right? So the normal linked list that we have right? So we have this node, and then this will point towards this, right? This will point towards this. Okay. Now this is the singly linked list. Now when it comes to doubly linked list, the doubly linked list, each node contains two links. The first link points to the previous node, and the second link will point to the next node in the sequence, right? So here instead of dividing it into three, we'll divide it. Sorry, dividing it into two, we'll divide it into three, right? This will point both sides, right? So what will happen here is we have the pointer for the previous, we have the for the next, and here we have the data. Similarly, previous, data, next. This will have the address of the next, this will have the address of the previous, and this will have the data. Now when it comes to circular linked list, it is the where the last node always contains the address of the first node. So here if there's a, so it's 1, 2, and 3. So these three. So now you have, here you will have the address for this one, right? Then here you have the address for this one. Over here you have the address for this node, right? So this makes a circular loop. That's why it's called the circular linked list. Now moving on to stacks. Now stack is an abstract data type which is bound with a predefined capacity. Now it is a simple data structure that allows adding, removing, other type of things that you can do to an element in a particular order, right? So stacks are like, when you stack a pile of books, right? So whenever you keep books one top of each other, so whenever you have to take out a book, you have to take it out from the top, right? So that is why this is also called as LIFO structure. That is nothing but the last in, first out. So the book that you keep in the last comes on the top, right? So that is why you have to always perform any function on that one. So whenever you have to pop, add, or delete, etc., then it happens only on the top of the stack, which is also called the end of the stack. Now overflow state. So a stack is said to be in an overflow state when it's completely full, and it is said to be in an underflow state when it is completely empty, right? Now when it comes to the applications of stack, it is very easily used to reverse a word, because when you push the given word into a stack letter by letter, and then you can pop the letters from the stack in the reverse order, right? And it is also used in phrasing, maybe expressing conversations, infix, postfix to infix, etc., right? So this was about stacks. Now stacks can also have the push operation, the pop, the top operation, search operation, etc. And this all, keep in mind, will happen only from the top of the stack, right? It won't happen from the bottom or in the middle randomly. Thank you.